Hello students, let us continue the session on trigonometry. We were solving NCERT exemplar questions. We had solved exercise 8.3 till question 12. Let's start with question 13 in this session. In the question 13, we need to show that the left hand side is equal to the right hand side. Here they have given the angles in terms of 45 degree plus theta, 45 degree minus theta, 60 degree plus theta, 30 degree minus theta. If you observe carefully, what you can observe is 45 degree plus theta and 45 degree minus theta, they are complementary angles. You can cross check it. If I consider 90 minus of 45 plus theta, what do I get? I'll get 45 degree minus theta. So these two angles, they are complementary angles. Same way, we have got 60 degree plus theta and 30 degree minus theta are complementary angles. So I'll consider the left hand side now. In the left hand side, we have given cos square 45 degree plus theta added to cos square. Instead of 45 degree plus theta minus theta, I'd like to write it as 90 degree minus 45 degree plus theta. I have taken this angles complementary divided by tan 60 degree plus theta into tan of, I'll once again consider the complementary angle of 60 degree plus theta. Now you observe we have cos square 45 degree plus theta plus now cos square 90 minus some angle will be sine of that angle. So complementary relation will become sine square 45 degree plus theta. Same way, here we have tan 60 degree plus theta multiplied to cot of 60 degree plus theta. Now you can make use of the identity sine square alpha plus cos square alpha will be 1, where I have considered alpha as 45 degree plus theta. Here tan 60 degree plus theta, instead of writing cot, I'll take the reciprocal relation, so it becomes 1 by tan of 60 degree plus theta. They two will get cancelled. We'll be getting result as 1 by 1, which is equal to 1, nothing but the right hand side. Hence we have got left hand side equal to right hand side. Hence we have proved it. Let's take up the next question. Question number 14 is an observer 1.5 meter tall is 20.5 meters away from the tower, which is 22 meter high. Determine the angle of elevation of the top of the tower from the eye of an observer. Here I would like to make a figure representing the situation. The observer is 1.5 meter tall. He is some distance, say 20.5 meter distance away from the tower. Here is the tower. The observer is observing the top of the tower and he is making some angle of elevation. Let me call the angle of elevation to be theta. They have given the height of the tower to be 22 meters. Now observe 1.5 meter I need to subtract here so that I'll get the opposite side of angle theta, what will be this distance? This distance will be 22 minus 1.5, which is 20.5. Now let me consider tan of theta. Tan theta will be the opposite side, which is 20.5, divided by the adjacent side, which is also 20.5. We get the angle as 1. So tan theta value, we get it as 1, which is nothing but tan 45 degree. So what does it mean? Angle theta will be equal to 45 degree. Therefore, the angle of elevation of the top of the tower from observer's eye is 45 degrees. Question number 15. Show that tan to the power 4 theta plus tan square theta is equal to secant to the power 4 theta minus secant square theta. Now we need to convert tan in terms of the secant. We have to make use of an identity. 1 plus tan square theta is secant square theta. I'll make use of this identity. How do I make use? Look at the left hand side. In the left hand side, we have tan raised to the power 4 theta plus tan square theta. I'll take tan square theta as common. I'll be getting tan square theta plus 1. Here, this tan square, I'll write it as secant square theta minus 1. And this 1 plus tan square theta is secant square theta. Now you multiply, we get secant raised to the power 4 theta minus secant square theta, which is nothing but the right hand side. Hence we have proved since LHS and RHS are equal. Now we have come to the last exercise of this chapter, exercise 8.4. If cosecant theta plus cot theta is given by the letter P, then prove that cos theta is p square minus 1 upon p square plus 1. Let me consider the given. Given is cosecant theta plus cot theta equal to p. I'll like to convert this cosecant and cot in terms of sine and cos. What do I get? This will be 1 by sine theta plus cot theta is nothing but cos theta upon sine theta, which is equal to p. There is sine theta, which is LCM. I'll be getting 1 plus cos theta in the numerator, which is p. Here in the question, we have p square minus 1 p square plus 1. So better I'll consider squaring on both the sides. I'll be getting 1 plus cos theta the whole square divided by sine square theta, which is equal to p square. I have squared it. Now sine square theta is nothing but 1 minus cos square theta. So 1 plus cos theta the whole square divided by 1 minus cos square theta will be equal to p square. Why did I write like that? I have written it. The reason is here I can make use of the identity. 1 plus cos theta, 1 minus cos theta can be written in the denominator and numerator. 1 plus cos theta multiplied twice. So this becomes 1 plus cos theta into 1 plus cos theta divided by 1 minus cos theta into 1 plus cos theta. This is equal to p square. This 1 plus cos theta will go cancelled. what do I get? I get 1 plus cos theta upon 1 minus cos theta will be equal to p square. There is another property which can be used. This property is called as componendo and dividendo. What is this property? Let me give a brief on this property. If we have a by b equal to c by d, then I can write as a plus b upon a minus b equal to c plus d upon c minus d. This property is called as componendo and dividendo. You can browse componendo and dividendo, Google it out and find it out. If I use this here, it becomes easy for me to solve. Here p square is nothing but p square upon 1. So by using componendo dividendo property, I'll write it as 1 plus cos theta added to 1 minus cos theta divided by 1 minus cos theta added subtracted to 1 minus cos theta. I have added the denominator and subtracted the denominator from numerator and denominator respectively. Here p square should be added to 1, then 1 should be subtracted from p square. What do I get? You can see here cos theta will get cancelled, we'll be getting 2 divided by 1 will get cancelled, we'll be getting 2 times of cos theta. Here I made some mistake here, a minus b, right? It is 1 plus cos theta. So which is equal to p square minus 1 divided by p square plus 1 divided by p square minus 1. 2 will get cancelled. This implies the reciprocal cos theta. Reciprocal, if I do, it will be p square minus 1 divided by p square plus 1. So what is most important for you to note is I have used this componendo dividendo property here. A plus b by a minus b, 1 plus cos theta plus 1 minus cos theta divided by a minus b, 1 plus cos theta minus 1 minus cos theta, which is equal to p square minus 1 plus 1 upon p square minus 1. This particular property is called as componendo and dividendo property. Most important, you can make a note of it. If this question is asked, if you use componendo dividendo property, it can be solved in a easier way. Alright, let's move on to the next question. We need to prove left hand side equal to right hand side. Let me consider the left hand side. In the left hand side we have root of secant square theta plus cosecant square theta. Let me change secant and cosecant in terms of sine and cos. So we get 1 by cos square theta added to 1 by sine square theta. If you take the LCM, in the numerator we get sine square theta plus cos square theta, which becomes equal to 1, and in the denominator we have got cos square theta multiplied to sine square theta. So in the numerator it becomes 1, in the denominator upon taking the square root, square and the root get cancelled, we will be getting 1 upon sine theta multiplied to cos theta. This is about the left hand side. Let me take the right hand side. We have tan theta plus cot theta. This tan theta can be written as sine theta upon cos theta, and here we have cos theta upon sine theta. On taking the LCM we get again sine square theta plus cos square theta divided by sine theta cos theta. We know that sine square theta plus cos square theta is 1 upon sine theta cos theta. Observe here we have left hand side and the right hand side equal, hence we have proved it. Question number 3. The angle of elevation of the top of a tower from certain point is 30 degree. If the observer moves 20 meters towards the tower, the angle of elevation of the top increases by 15 degree. So from 30 degree, 15 more to be added, it becomes 45 degree. Find the height of the tower. Let me make a figure. Let me consider the height of the tower TW to be some x. Observer is observing from some point A by making an angle of elevation of 30 degree. He moves 20 meters towards the tower. From that point, the angle of elevation increases by 15 degrees, so it becomes 45 degree. Let me consider the distance of the second point where the observer is making an angle of elevation 45 degree to be y. Now if you observe tan of 45 degree is x upon y. We all know that tan 45 is 1 is equal to x by y. We get x is equal to y. Now observe, if I take tan 30 degree, this becomes x upon 20 plus y, as this equation says, equation 1 says x is equal to y. I would like to substitute in the place of y as x so that I can find the value of x. This implies 20 plus x is equal to root 3 times x. So 20 will be equal to root 3 minus 1 time of x. So x will be equal to 20 upon root 3 minus 1. I can rationalize the denominator by multiplying root 3 plus 1 to both numerator and the denominator. It becomes 20 times root 3 plus 1 divided by 2. Hence it becomes 10 times root 3 plus 1. Further, if you consider root 3 as 1.732, then it becomes 10 times of 2.732, which is 27.32 meters. Question number 4. 1 plus sine square theta equal to 3 times of sine theta cos theta. Prove that tan theta is equal to 1 or 1 by 2. How do we go about this question? We'll make use of this given. It's given that 1 plus sine square theta equal to 3 times sine theta cos theta. Let me divide both the side by sine square theta. What do I get? I'll be getting 1 upon sine square theta plus sine square theta by sine square theta equal to 3 times of sine theta cos theta divided by sine theta into sine theta. Here one of the sine theta, sine square theta are getting cancelled. 1 by sine square theta is cos square theta, cosecant square theta plus 1 equal to 3 times of cot theta. Now this can be written as this particular thing, cosecant square theta can be expressed as cot square theta. We know that 1 plus cot square theta is cosecant square theta, so 1 plus cot square theta in the place of cosecant square theta plus 1. Let me transpose this 3 times of cot theta to the other side equal to 0. Here we have 1 plus 1 added becomes 2. So cot square theta minus 3 times of cot theta plus 2 will be equal to 0. Now little trick. The trick is I should be in a position to take something common. Suppose if I write this as cot square theta minus 2 times of cot theta minus cot theta plus 2 equal to 0. If I do that, I have changed this 3 times of cot theta into minus 2 minus 1. So if cot theta is taken common, I'll be getting cot theta minus 2 minus 1 taken common, we get cot theta minus 2 equal to 0. This implies, I'm writing it on the top, cot theta minus 1 multiplied to cot theta minus 2 equal to 0. We get cot theta as 1 or cot theta is 2. If you take the reciprocal now, 1 by cot theta will be equal to 1. This implies tan theta will become 1 or reciprocal tan theta will be equal to 1 by 2. Hence we have proved that the value of tan theta is either 1 or 1 by 2. Question number 5. Given that sin theta plus 2 times of cos theta equal to 1, prove that 2 sin theta minus cos theta equal to 2. Let me write the given sin theta plus 2 times cos theta equal to 1. To get 2 times of sin theta minus cos theta equal to 2, I'll do squaring on both the sides. If I square, I'll be getting sin theta plus 2 times cos theta the whole square equal to 1 sin square theta plus 4 times of cos square theta plus 4 times sin theta cos theta equal to 1. Here, if I consider it has 1 minus cos square theta in the place of sin square theta, I get 1 minus cos square theta plus, in this if I write 1 minus sin square theta, I'll be getting 4 minus 4 times of sin square theta plus 4 sin theta cos theta equal to 1. Now you observe this 1 and the right side 1, they get cancelled. We will be getting minus cos square theta minus 4 times of sin square theta plus 4 times of sin theta cos theta equal to negative 4. Now I can completely multiply with minus 1 so that it becomes cos square theta plus 4 times of sin square theta plus negative 4 sin theta cos theta equal to positive 4. Why did I do like that? Here we have 2 sin theta minus cos theta. Here 4 times sin square theta is there. Here cos square theta is there. To simplify further, I will write this as cos square theta plus 2 times sin theta the whole square minus 2 times of cos theta into 2 times of sin theta. I can write it like that, equal to 4. Now you observe it is something like a square plus b square minus 2ab, so which is cos theta minus 2 times sin theta whole square equal to 2 square. I'll write 4 as 2 square. Or it is also same as 2 times sin theta minus cos theta the whole square, which is equal to 2 square. Both are the same values because when you square it, square of a negative number will be positive, so this holds true. So we get 2 times sin theta minus cos theta equal to positive 2 by taking square root on both the sides. Hence we have proved it. It is little tricky. You keep solving, you will understand it. Next question. The angle of elevation of top of tower of 2 points distant S and T from its foot are complementary. Prove that the height of the tower is root of S into T. As per the question, if you have a tower, say TW, if TW represents a tower, there are 2 points which are at distance S and T. Suppose if the point here is making an angle theta, this will make complementary angle 90 minus theta. If this distance is taken as S, the other point distance should be taken as T. Let me name this point as A and this point as B. Alright, let me consider the height of the tower to be X. According to the question, tan theta will be X by S. Same way, if you have tan of 90 minus theta, this will be X by T. Suppose if I consider this as equation 1, further I'll simplify this. It will become cot theta, which is equal to X by T. Let me name this as 2. Let us multiply 1 with 2. This implies tan theta multiplied to cot theta equal to X by S multiplied to X by T. These two will get cancelled. On multiplying, we get St is equal to X square. So the value of X is root of St. Hence we have proved that the height of the tower is root of X St. Next question. Question number 7. The shadow of a tower standing on a level plane is found to be 50 meters longer when the sun's elevation is 30 degrees than when it is at 60 degrees. Find the height of the tower. I'll make a respective figure. Let me consider again tower to be some TW. It should be a straight line. I will make a straight line. Consider this to be a straight line. TW. The angle of elevation is 30 degrees and 60 degrees. So this angle is 30 degrees and this angle is 60 degrees. It is given that it's found to be 50 meters longer than the sun's elevation at 30 degrees than when it is at 60 degrees. Suppose if I consider this distance to be y, tower height as x, this distance will be 50 meters more, so 50 plus y. Right, now I'll consider tan of 60 degrees. Tan 60 degree will be equal to x upon y. Tan 60 value is root 3. So root 3 is equal to x by y, or x is equal to root 3 times y. Let me call this as equation 1. Now you observe tan 30 degree. This will be x upon 50 plus y. Tan 30 is 1 by root 3. This is equal to, this will be root 3 times y divided by 50 plus y. This is from equation 1. Let us simplify this. On cross multiplying, I'll get 50 plus y equal to root 3 multiplied to root 3 will be just 3 times y. So 2y will be equal to 50. So the value of y is 25. They have asked us to find the height of the tower, so the height of tower will be equal to root 3 times y, which is 25 root 3 meters. Let me consider one more question as last question for today's session. This bit trickier one. A vertical tower stands on a horizontal plane and is surmounted by a flagstaff of height h. At the point on a plane, the angle of elevation of the bottom and the top of the flagstaff are alpha and beta respectively. Prove that the height of the tower is h times tan alpha divided by tan beta minus tan alpha. This result is one of the important result. It was asked in UPSC examination. Respective figure, I'll draw it. There's a tower. Say TW is representing tower. On the tower, it is surmounted by a flag staff, which is of the height h. So let me consider this as a flag staff. From the flag staff's bottom, we have the angle of elevation, say alpha, and from the top we have the angle of elevation beta. This angle is beta. Let me consider the height of the tower to be some x units and distance of the observer from the foot of the tower as y units. Look at the figure. We have tan of alpha equal to x by y. From this, y value will become x upon tan alpha. Let me name this as equation 1. Once again, observe tan beta will be equal to the distance x plus h divided by y. Now I will replace y with x by tan alpha. On cross multiplying, I'll be getting, this is from 1. On cross multiplying, I'll be getting x times tan beta upon tan alpha equal to x plus h. Further, I will cross multiply. I'll get x tan beta equal to x times tan alpha plus h times tan alpha. So the value of x will be x tan alpha plus tan h tan. Sorry, I have to take x term to the one side. I'll do that first. X, if you take one side, x can be taken common. I'll be getting tan beta minus tan alpha equal to h times tan alpha. So the value of x will be h times tan alpha upon tan beta minus tan alpha. So this is the result we were supposed to get. This is the height of the tower. With this, I'll conclude today's session. We shall see the remaining questions in the next session. Thank you.